Yo, good morning, good morning. Okay, so the plan today is to continue with the activity texture. We are currently implementing snow, and that's just I wanted to do something practical. I wanted to do something with the activity texture to see, like, to try and figure out what data we need and how we need it a bit better instead of just having it in theory. And we just began implementing the snow yesterday, and maybe we can continue with it today. I don't know. And when I say snow, I don't mean any of the visual stuff, although deformation is visual, but we're gonna focus on the visuals now, and we're gonna wait with I'm talking about light, glitter, and stuff like that for snow. But yeah, I want to make this deformation, we can see here, look a little bit better. Probably exists quite a few ways to do it. But we will see. So what we see here right now is an extremely simple implementation of it. We pretty much just check if we have any height data at this point, then lower the snow. That's about it. Then we probably want to let's see what we want to do. We did it something. We're gonna do so like this: improve node shader visuals. Then I want to do improve node shader displacement. Because we can clean this up quite a bit. Although I am a bit... I am a tiny bit scared of how one would clean this up. We're probably gonna have to depend on neighboring vertices or neighboring data. But if we're gonna do that, then it's gonna be a problem at the edges. But yeah, we don't need to care about that now. We can fix that later on. And then we probably want to try and avoid, like, I want to see how good deformation can we get from only having the height data as information. So the minimum height that traversed a point. And I'm also thinking, like, how we want to fix this. This jagged, we probably want to go, we want to do a quad lip here. Good morning, Geralt. How we want to solve this as well. Like, if we have something like this, so we have a vertex where every neighbor is deformed in some way, we probably will want to bring this down a bit as well. If we were to flip this one, sure. Yeah, I think the easiest way to improve the visuals of this without going into any quad flipping just yet would be to base the deformation a bit on its neighbors as well, right? So if the deformation, we can do something simple, and let's experiment a bit with this. But if the point we're currently rendering, if the vertex we're currently rendering, we read all of its neighbors, and then we check if this one has the smallest min value, just offset it to that min value. If it doesn't, we're gonna have to calculate it somewhat based on its neighbors, and we're gonna calculate the normal there as well. Like, we need the neighbors either way because we want to calculate normals here, right? So maybe we should start with that. I'm wondering if we want to do... let's do this. Let's just experiment a bit with snow today. I've been also wanting to... Like, I've been wanting to do a nice snow shader for a while. And then I'm not talking about deformation. I just want to make a snow shader that looks good, right? And I think you can... make a lot with simple stuff like rim lighting and some sort of noise glitter, because you know when the sun is on snow, you can see it's almost like it's glittering, right? But yeah, so let's add some tasks here and go through them. So yeah, I know I said we won't be focusing on the visuals today, but maybe. It's just what I feel like. Improve shader displacement. And recalculate normals. Flip quads or smoother shells? Question mark. I'm not too sure. Recolor base on displacement height. I just want to make, like, I want to differ a bit more. The white here and the white here should be, this one should be a little bit darker, I think. Even though the normals for them are exactly the same, I just want to darken this a bit. What more? Experiment with offsetting height based on neighbor heights. And here I just want to add rim lighting, add glitter highlights. Anything else? This might be a good start. I think, let's do this actually. Calculate normals, calculate tangents, and recalculate by tangent. I just want to do a quick commit as well. We didn't commit this one yesterday, so the current state of it, I want to commit it. Because I mean, it's definitely far from perfect, but works, although very, very, very simple. Pretty fucking cool, actually. Like it. Although, yeah, we're probably gonna tessellate it as well. Yeah, that's true, that's true, that's true. Some really bad performance at the moment, but I think that has to do a lot with all of the different meshes we have here. The resolution of them. We render far away in full resolution as well. So yeah, a lot of things to optimize, but we're not going to focus on optimization right now. We can have it open, see if we're at roughly. Okay, so I also want to add so tessellation is, so let's put it like this. I want to see what we can do to improve the snow shader displacement and recalculations of vertices without tessellation. And then we can try it with tessellation as well. I think tessellation can do the most for us, honestly. Okay, but first of all, let's just commit this real quick. On 31. Okay. Let's start by recalculating normals, tangents, and bitangents. And I'm pretty much just gonna take to properly do that, we're gonna have to send in a few more things. I think we're gonna have to send in we're gonna have to get distance between vertices. So I'm talking about, don't we have it here? Right, base. I think we're gonna have to send in the delta. So it's the distance in world space. And we don't scale these, so it's the same in object space, but the distance between vertices. Sure. Yeah. But I also want to do some quick, we're gonna see here. Let's hit that one. Jump to the snow terrain. I want to set this one to 0.5 by default. And height offset to 0.2 maybe. Well, let's go a little bit crazy with that one. 0.4. And probably never gonna have more than 2 meters of snow, so let's change the range. And okay, before we do these, we're gonna do the easiest one. And I'm talking about this one. I want to do it with colors, I think. So we're gonna do color, specular color. Lowered color. And we're gonna do a lot of things in the, like we do a lot of recalculations and stuff in the vertex shader. We do the colorization in the fragment shader. So it's a matter of what information do we send onwards from the vertex shader to the fragment shader. We only want to send exactly what we need and not too much. And yeah, eventually if we do tessellation for this one, we're going to send in a lot more. But when it comes to this recoloring, it's basically, I just want to recolor it a bit based on how trampled it is. So it's eventually going to be this one. Or not this one, but this one minus... we might want to get some correct height displacement based on the height minimum. So let's do use, or properly use activity data dot height boundary displace. We can start, okay, I think we're gonna start with this one, then we're gonna do this one, then we're gonna do these three, and then we'll see. So basically right now we displace it by just doing, if something has traversed this one, put it down to its original position OS, otherwise offset it upwards. So I guess what we want to do instead is we want to do position OS is this one plus the height offset, but then we want to offset it by this one. Although I wonder, right now height boundary is this right here. So we take the position in world space, normalize it to height range. So this is always a value between 0 and 1. 0 being height range X, 1 being height range Y. So we have access to height range here. We don't. So we want to set that one first. Height range, and this one we have used a lot. Basically what this one is it's defined in terrain base, I think. Yeah, here. It's the minimum height our terrain can have and the maximum height our terrain can have in world space distance. So for instance, if we have a height range that is 0, 2, that means that our terrain can be at Y position. So terrain object position Y plus height range X to terrain object position Y plus height range Y. And if we send in this one, we can probably use it for something good. Let's see. We can definitely get where we at here. Yeah, we're probably gonna work with it like that. Yeah, so let's see if we can send this in real quick. And we have terrain base. So currently the solution for switching to a snow environment is not the best one, but we're gonna have to work with this one for now. So we basically want to set it here to shore. It's perfect. Is it height range? Yes, it is. We have it here, height range, and we have it here. So pretty much serial copy set vector this one is a range, so we're gonna do vector. So now we have a height range here, and then we can do, I wonder if we want to recalculate the position OS to be within this. Like if we want to normalize it to height range. If we take a look at this one, we use height range here, so I think that's a good way to do it. So we're going to start by doing float position, or call it y position OS. Inverse lerp 01 input position. Inverse lerp 01, no, inverse lerp or actually no, we want to do 01 inverse lerp 01 bounce value. Height range xy input position os.y. So now we get the position between 0 and 1 as well. So the same range we are working the height boundary. Pretty sure. Although I wonder. Yeah. So if we want to get the real position here, we do y position OS plus equals to height offset. So now we have offsetted it as if it wasn't trampled. And then we could add the offset for the trample, which should be equal to minus equal to or actually the value we have in activity data height boundary X is actually the height it should have, right? But then again, if we don't have any, I want to be careful what we do here. If we don't have any data for this point, we haven't put it at 0, but instead we have it at 1. So yeah, we need to take that into account. which makes me wonder if we just want to do, we probably want to do, we can do, could it be as easy as activity data dot terrain or height boundary dot x multiplied by height offset? So this one is 1 if we haven't trampled it at all, which means that we're going to offset by height offset. It might be 0.3. And we're probably going to get... So if it's at 0... we can't really do it like this. Alanim, thank you for the follow, appreciate it. It's not as straightforward as this. Okay, so this is good. This makes me think about how we want to package the data to actually make it useful. I'm starting to think that packing it as normalized object space position might not be the most handy way to do it. Because we're gonna have to do... but what we could do is, we could calculate a multiplier here. So this displays multiplier. Now we're gonna try and calculate how much we should offset it. So it's basically if height boundary x is equal to y position OS, then we want the displace multiplier to be 0. If it's above y position plus height offset, we want it to be 1. So could we not just do inverse lerp 0, 1, and we do y position OS, y position OS plus height offset, and here we do activity data height boundary dot x, and then we take this one and multiply here. So if this one is less than or equal to this one, we get 0. If this one is more or equal to y position OS plus height offset, we get 1. And then we interpolate or inverse interpolate between those two. And this one is always between 0 and 1. We multiply it with height offset. I think that's pretty good. And then we can do float 3 position OS is equal to float 3 something like that. And yeah, then we use this one here, but we don't need to do this. So displace recalculate world space position, clip space position, And we want to do this stuff as well. But let's see what we get from doing these calculations. I'm not 100% sure, but we might as well try it. Or test it. Seeing the time it takes to generate the terrain with this resolution, like I probably want to go through and optimize the generation. And eventually, this looks pretty good, I would say. It's hard to see with the current shading, unfortunately. But if I jump, we can see that's pretty good. Still quite a few things, or quite a long way to go, but it's a start. Just want to see what happens if we displace this one a little bit less. Oh, nice. Yo, good morning, Love and Harukanan. Love, good morning, bro. Long time no see. Yes, indeed, long time no see. Hope 25 is treating you all right so far. And it's going pretty good. We're finally... we managed to migrate the project to Unity 6, which I think is very nice. So now we're at the latest Unity version. We migrated from 21.2 to Unity 6. I think that's about 3 years of engine improvements we got from that one, so that's okay. And as soon as we finished that one, we went back to the activity texture, and now I'm playing around with the values we have in the activity texture. Like, I want to see if we store them in the correct way, etc, etc. So I want to use them for something, and the most easy thing to use them with is snow. So we started with snow. That's where we're at, pretty much. Doing some simple deformation, which is not extremely visible right now, but we're gonna get to it. We're gonna improve the visuals of it. We can go, let's try and do it. Let's do it this much. So the new implementation of snow, yeah, we can see here that when we jump, we actually follow the trajectory of the character pretty good. I don't know how visible it is here, but so now we only deform the snow, or rather, now we deform the snow the correct amount. So we can see here the character ran and then he jumped. We don't deform it as much here. More here. So yeah, that's pretty good. Don't think we will ever support this much snow, however, this high. Although I wonder. I'm a little bit worried about... So at this point we're above the stomach in snow amount. Here we are I'm wondering if we get... Yeah, the displacement doesn't seem to work. Maybe I've screwed it up when we changed it a lot, so let's take a look. Yeah, I think the displacement we have... Yes, okay. So the displacement upwards on the snow amount is... It's tied to the terrain height. So we can see here we don't barely have any snow. Here we have a lot of snow, and that's not good. So let's take a look at that real quick. Yes, of course, because we need to do... Before we do this one here, let's do it like this. Position OS. So basically what we put in, oops, the final position in object space here that we put in is has a Y position that is still normalized to height range. I think this is it. So what we want to do is lerp, and we want to do height range.x, height range.y, and Y position OS. I think this is, or was the problem rather. And maybe, just maybe, we can lower the resolution of the terrain a tiny bit, so we don't have to generate it as much. Do we have... No, we still... It's still a little bit weird, isn't it? Yeah, it is. I think the best way to show it is doing... Or is it? Oh, I know what it is. I know what it is. Yes, okay, but so now we generate it the correct way. It's just that how height range works is a little bit weird. Or if we do it like this, we will never be able to get terrain plus snow that is greater than height range here, which sucks. So we're probably gonna have to do this lerp twice, a little bit unoptimized, but we can focus on that later. So it would pretty much be... Or we could do this. Let's see. Would that make sense? I don't think so. Or it would. We could probably add height offset to this one and lerp like this instead. So now we take... So the maximum height terrain plus snow can have is equal to maximum height of terrain plus height offset. But this will probably screw it up, or will it? If we have a displacement multiplier by 0 here, so then we just get Y position OS, but then we lerp it between a bigger range, so we will probably offset it too much. So a better way to do this would probably be to do, let's see here. To work in this range from the get-go. So we do float, or rather we don't do this, and instead we do float height offset is equal to lerp height how do I want to do this? Should be height offset is equal to lerp we're going to go to displace height is equal to lerp height range dot y activity data height boundary dot x. So instead of having the so this is the minimum height that the vertex has ever been traversed at, if that makes any sense. So if something occupied this vertex, this is the height it did it at. But this height is normalized between this one. So this height is between 0 and 1. 0 is equal to this one and 1 is equal to this one. So we pretty much unnormalize it here. So now we have displace height in object space. And so then we don't need to normalize this one to 0 and 1. So now we're working in object space here. And displace multiplier position OS Y position OS plus height offset, and this one we can probably displace height. And then we don't need to do this one here. Makes sense. So get the minimum Y position of the object that traversed this vertex. Bring it into this range. Let's try it. And I wonder if I want to do, yeah, maybe we do environment 2048. Let's just do it like this. 1024 164. Let's see if we can speed up the creation a bit. Maybe a little bit. And do we have... Oh, no, we still have this issue. What am I not getting correct here? Knees. Or actually, do we? I think, yeah, we do. Let's bring this one down. What do we have? 0.4 minus 0.4. Yeah, it becomes quite visible at this point. That we're offsetting it. The heights are not getting offsetted as much. Yo, what's up, E-Dragon? Creating some Wukong sand physics. Yeah, I'm trying to play around with the activity texture data, like what we store in it and how we utilize it. And I'm doing it by implementing the simplest thing that is going to use it, and that is snow. But a sand definitely works as well. Long time no see, by the way. Right? But right now we can't even get the simplest thing to work. I'm doing something a bit wrong here. Maybe I need to draw some stuff to fully grasp what's going on here, but let's see. Displace height. Okay, so I know that if we don't displace it, we still get the wrong. So let's not worry about this one too much, although we do it here. Displace multiplier. Yeah, I think it's this one. Yeah, this is not how we want to calculate it. We want to calculate it by... If this one is at this position, we want 0. That's true. But we want to do... Actually... yes, okay. This might result in a bigger value than this one can be, because we're doing this. And that's why our tops don't get as much snow. Okay. So the question is... we don't want to do a lerp here. We want to do... I think we can calculate it like this. Displace height is equal to activity data dot height boundary dot x minus y position OS. Can we? Utilizing height range here limits us a bit. eDragon can do really cool stuff with it. I'm playing MX Bikes, which is a motocross game. A motocross game that so a lot of dirt, I guess. Yeah, so like we have a few things in our activity texture right now. Right now we're only playing around with height. So if something occupies a point, we put its minimum height into the activity texture. And that one we can use for a wide range of stuff. And yeah, I want to use it for dirt, sand, but also snow. So yeah, I can imagine like a modern motocross game probably uses something similar a lot, and I can imagine it looking very, very cool. Also, like in our case, in the activity data, we also have velocity and strength. So if something occupies a point, we write the velocity and strength of it to a texture. And with that, you can do, like when we run in the snow, we know in what direction we want to throw particles, for instance. We're going to be able to do so many cool stuff here, I think. But the question is how, like, we don't want to go overboard either. We still want to keep it relatively simple. But okay. How can we get around being tied to the height range in this case? One sec. Okay. Let's do some drawings here so I can hopefully explain the problem we are facing. Make it a bit more, make a bit more sense. Hopefully we can find a solution. So our terrain, it has a minimum height and a maximum height. And this is our height range. So height range Y, height range X. These two are these two. So our terrain, the ground, can always only be between these two, right? So Y position OS is always between these two. When, this is what I don't like. If we have an object, if we position an object here, what we render to the texture, put it here, is that we take the position, its lowest position, this one, and then we interpolate it between this one and this one. So this will roughly get 0.45. Here. this one will get, so if we have this one will get 1. This one will get 1 as well. And this might screw us over, because so there's pretty much no difference between these two. So if we have an object that is, I don't know, flying above the maximum height, when we write this one to the texture, we're gonna write it as 1. So when we pack it up, it's going to be the maximum height of the terrain. So if we have snow, here, this one is gonna displace this snow as much as this one. And this is, so here's one thing that might not be, yeah, this is not a good thing. So it's probably something we want to rework in the packaging state. I wonder if it was that smart to base it on or normalize it to height range. Instead, what we might want to normalize it to is, or we might actually want to normalize it as, we could package it as distance to this one. We have to be careful as well, because we know that we're going to package this value into 8 bits. So we pretty much only have 256 different values it can have. But one could think that instead we package the distance to the terrain. So here we have 0, 0. This one is, I don't know. This one is something else. I don't know. What's up, Bashiro? I'm doing fine. How about you? E-Dragon, but you're using one Unity height map thingy. We actually have, like, short answer is yes, but our terrain is based on our own system. But we basically have one height map as a base to calculate the terrain height, yes. It's very similar to the Unity solution. We could also package it as, yeah, maybe that's a better, we will never go below this, never. So I mean, we could package the minimum as a float value between 0 and 1. We could still use these. But, so we take the distance to the ground. So we take this distance, and then we calculate how big is this distance relative to the max height we can have. So we do it, if we call this one, and let's call it D, so we do it as D divided by HRY minus HRX. So in our current setup, this one is 0, this one is 1. Here we have 0, so we will get 0. Here we have 0.3 in this case, will be 0.3. But so like it's relative offset to ground. I think that might be the better option, honestly. The only negative aspect of this is the fact that we're gonna need the height of the... So currently when we draw this down here, actually, do we? Yeah, so we're gonna need the height of the terrain when we draw this output. But that is something I've thought about having here either way. But that's also something I would like to avoid, I think. Because if we want to have it here, what we're gonna have to do is in terrain base, when we write the activity, we're gonna have to set the texture. And I mean, if we don't render, if the camera is looking the other way, we probably don't have these textures in easy accessible memory. So it's probably not the best choice either, honestly. The more I think about it, like I don't want to, when we write to the activity texture, we want to use as little data as possible, I think. So keeping it clean like this is probably preferable. So yeah, we're gonna wait with that one. Ashiro, how do you save the new height map texture file? Like, how does the file get updated in real time? I don't like to say this, but I think our previous solution was a little bit better. Previously, we relied on... I wonder if we have it left. We have done two different approaches to it. So to update the height map in real time, initially we used Blit, but then we actually changed the terrain data to use compute buffers instead. So it's basically just one long array. And we store it as a one-dimensional array, but it's actually a two-dimensional array, right? So much like a texture. And then we just change these values like this. This is highly experimental, and we're probably gonna add a... I'm not entirely sure if we want to do the compute buffer solution either. I like the Blit solution the most, because when we did it with Blit, we altered the height texture on the GPU, right? It was very quick. But with the current implementation, we still need the data on the CPU as well. So we did a Blit, and then we read it back to the CPU, which is not preferable. Eventually, I'm starting to lean more and more towards having it only on the GPU. That's not entirely true either, because we're still gonna need to do, when it comes to the actual terrain, we still need to do, we need to have the data accessible for the CPU to do collision detection, right? Yo, what's up, Fifth Function? Thank you for the raid. Hope you had a wonderful stream. Appreciate it. So Ashiro, as to your question, it changes a lot. We're still experimenting with stuff, but for now we're using compute buffers. So we store the data both on the CPU, because we want to do physics calculations with it, and we store it on the GPU because we want to render it, right? Not a big fan. Like, we can do a lot of improvements here. But when it comes to the activity texture, that's a whole other thing. So the activity texture, that one we only store on the GPU, because we don't need that one on the CPU, right? So that one is way more optimized. So when we update it, we do it by we pretty much do it by renders. Or here we have a compute buffer, and we tell it to render certain objects with certain setups. So activity texture entirely done on the GPU. That's very, very cool, I think. But height map and terrain, not optimal at the moment. But okay, back to this problem. So I don't want it to be relative to the terrain height. So I'm thinking the only option we might have here might be to introduce a new range here. How can we do it? Do we need to define something project-wide, so to speak? So something very similar to height range, or can we do it? Can we do some nice magic just in the shaders? We could probably do it like this, although not entirely sure about this one, but let's try it. Procedural snow. It's very important. So this is, we pretty much have a similar problem as you have when you write shaders and you work in all of these different spaces. Object space, world space, tangent space, whatever. So we work in like object space, height range space, so on and so on. So it's very important that position Y and activity data height boundary X are defined in the same space, right? I don't think we can get around So I have one solution in mind. It won't solve this issue, but it will solve the this issue. So we have snow here that doesn't get added at the correct height. So we will solve this issue, but I don't think we will solve this one. But I think that's okay for now. So what I'm thinking about doing is, if we do this, float y position height range is equal to inverse lerp 0, 1 height range xy and input dot position dot y. So now we have the position of the terrain in height range space. And then we do float displace height in HR is equal to, and then we just read this one. So now we have the y position in height range space, and we have this is displace height in height range space. So same space. And then I wonder if we want to do then we can do float. We're gonna do, let's do like this instead. Displace height. Shall we do minus y position HR? So now we get the distance between the terrain and the displace. The distance here, and then we do float displace multiplier. It's equal to lerp between 0 height offset displace height HR, and then we have the displace multiplier. So basically what we want to do is y position OS plus displace multiplier times height offset. Does this make sense? I don't know, but let's find out. First, let's see here. So we take position in OS, we normalize it between height range, so it's between 0 and 1. This one is already between in height range, so we take this one. We always assume that this one is bigger than this one. So we get distance in height range space. And then we lerp here, and this is in object space. Let's try it. Yeah, input.position.y. I wonder if invalid subscript position. Yeah, position OS. But then again, even if this works, it won't solve this issue with flying objects. I don't think. No, it won't. Do we only have... .4, is this actually this? This doesn't seem to be right. So let's put it at 1. What am I missing in these calculations? Also, I think this one is redundant. So I think, yeah, our position in object space will always be... it's not redundant, never mind. Yo, what's up, Cypher? Yes, okay, I get it. Displacement height if we want to do this, we're gonna have to do between height HR, we're gonna have to do height OS is equal to displays height HR divided by height range dot y minus height range dot x. But then again, I don't think if height range is 1 and 0, this won't change too much. Let's take a quick look at it. 1, 0. All good, buddy. Nice to hear. Nice to hear. Same here. Same here. I'm having a little bit of a slow morning, to be honest. But we're doing pretty cool stuff, so I'm okay with it. Why doesn't this make any... Or why doesn't this produce the correct result? Let's see. We want to do this, but that's not the problem. Oh, yeah. What the hell? What the fuck? I want to do this. This one we want to be between 0 and 1, not 0 and 0.4. If this one is bigger than this one, we don't... Something like this. I thought this height range stuff was pretty... I don't think we can do it any other way, but it's coming back to bite me. Does this look correct? No. But then again, this is a... Yeah, this is a problem with... Seems to work at certain places, but at some, not at all. Shouldn't be this complicated. So basically what it comes down to, in the end, what we want to do is in the end, what we want to do is this. And this one we want to be between 0 and 1. I don't understand what's wrong in these calculations here. In fact, it should be as easy as this, honestly. Float displace multiply should be equal to inverse lerp 0, 1 between input dot position os dot y and plus height offset. And then our t, because basically like this should be our display's height. The question is it's a pretty straightforward problem, really. So lerp so this right here, this is the correct calculation. To take the height boundary, make it between height range x and height range y, and then we do an inverse lerp between the ground and this one. That's what we offset it by. But the reason why this doesn't work is, once again, like if we don't have any activity for a point, but the terrain height for that point is 1, then we will pretty much get then this one will become this one, and then we will get, why won't this work? If we have 1, this will be equal to this one. And yes, this one is equal to this one, so we get 0. Like the easiest, most straightforward solution for this. So I guess let's assume these calculations are correct. And then we jump to terrain base. We take a look at height range. We have this one in terrain patch as well. Height range in here as well. like the most straightforward solution, and which would work and give us the correct result if we duplicate this one and we have a height range for the ground, and then we have a, I don't know, height range for the boundary of the terrain. Nothing can go. We have a secondary boundary height range. I guess we could do, I wonder how weird it would be to do plus height offset here as well. Problem is, once again, that this one can never be bigger than this one. Never, never, never. But so let me show this by doing, if we have this implementation, then we do rain patch, generate values, scale. If we were to do generate values, set value, generate byte value, we do 0.5. Generate byte value. Can't we do this? Or are we gonna have to? Yeah, we're gonna have to throw it again. So if we just do this real quick, generate value, here we do 0.5. We have a height range of 0 to 1, but we only generate our terrain to be between 0 and 0.5, so we lower it a bit. Which means that we should be able to have this one should be able to be equal to this one. We want to fix this one as well, then do we? Maybe not. Same problem. Frustrating, frustrating, frustrating. But then if we do did I change the correct value here, by the way? I think so. Yeah, how can this possibly be wrong if we don't take into account... Okay, so we know that position OSY, at most it can be half 0.5 height range Y. So displacement height, we move this one from 0 and 1 to be between height range X and height range Y. And then we take this one, so that's in object space. Then we take this one minus this one. So we get a distance in object space, and then we inverse slurp, so we either get yeah, so if this one is bigger than this one, we get 1, but if this doesn't work, the only thing I can imagine is that when we generate the values, we don't generate half values. So knee deep. Now we have... No, we don't. Or do we? No, we don't. Feels like I'm missing something very basic here. Minus 0.4. Okay. Why don't we offset it more? Course. This one is wrong. We just do no. But if we did, what am I missing? Height boundary, height range, displacement height. Yeah, this gives us a distance. We don't want to inverse lerp here, but we want to do... Oh, yeah. Think. This gives us a distance. And we just want to divide this one by height. So could it be this? Displacement height. So this is between 0 and 1. When we pack this one into the texture, we do inverse lerp, height range x, height range y, and a height value in object space. So we just repackage it in object space. And we take the object space height minus this height. So then we get a distance. And then we divide it by this one. 0, 0. But then we can get, and we want to saturate this one as well. I wonder. This shouldn't really be... I shouldn't really need to put this much time into this thing, but this one does really screw things up, unfortunately. Okay, this is not good. But the snow offset and the ground offset is at the correct height, or synced at least. That's something. Because we want to do inverse lerp here. Fuck, do we? Yeah, we do. Inverse lerp 0.1 is probably we want to do. Okay, there we go. Think. But this is probably not the solution. Yeah, okay, now it's synced. That's nice, but as we can see, we can only go as far as high as if we go above 1. It doesn't work. Okay, so it still doesn't work entirely for our biggest. If we do 0.5. Yeah, this is not really how we want to do it. Get this here. The tops are still not handled correctly, and I wonder... So, this one should still work. Displace multiplier. If the generation works, we have So this one is at most 0.5. This one can be at most 1. So worst case scenario, let's see, we get 1, or at the top we get 1, 0.5. This one is 0.5. If a distance of 0.5. Yo, what's up, Fabic? Sorry for the distraction. No problem at all. Really could need different viewpoints here, but let's see. But for the calculation, are you using the terrain height or the terrain max height? Yeah, like, all this problem stems from the fact that we have this constraint that we only render the terrain. Like, we work with normalized values at all times. So we try to express the terrain height, the displacement and all of that in normalized coordinates to our height range. And the issue is basically that at the tops we go above our height range, which gives us this problem. So we just need to figure out how to mathematically get around this. But if I have limited this correctly now, so we should never get terrain that is greater than 0.5 times height range y. So I really don't understand. So if we take a look at dynamic output, minimum height, what we do here is we do inverse lerp 01 height range and the position in world space. Yes. I think that should be... We have to be careful about that one as well, but our environment is at 0, 0. So it's okay. So what we calculate here, displacement height, where we're calculating this point in object space. This gives us a, like, the distance from where the object, the distance from the height we rendered, or between the height we rendered into the texture and the position of the terrain. And is it just as simple as doing plus minimum of this one and height offset? Yeah, we're calculating the distance between... Yeah, maybe it's like this. We calculate the distance to the ground. This is crazy, I don't get it. I don't get it. Mm. Now I'm at a point where I'm starting to not question this code, but questioning the other code. Fabit, can you make a slope terrain going from 0 to max and try the shader and see at the height it starts to break? It will help you narrow down the problem. I think I know what the problem is. It's just not how to properly get around it. But we might do that soon. I just wonder how much time that would take. We can probably do... Yeah, this is where it starts to break. It's pretty apparent that when we get to max height, we are fucked. I'm starting to think... Actually, let's do this. The terrain generation might not limit it to... Let's add 3D object, plane. And then we add it at... This is at 0 height. Zero 0.5, 1. 0.5. Yeah, we actually generate noise that is higher. Okay. That explains it. Okay, so this is the problem. Not doing what I think we're doing when we generate the terrain. So these calculations, I don't see anything wrong with them. Data value generation Y. 0.5. What the fuck? Very good input, Fabric. So I think the problem might not be in the snow shader at all, which makes sense. I've been looking myself blind at it, but actually when we generate it. So I'm just adding a constraint to the terrain here. So let's see if we get the correct values now. Let's add a plane again. Let's bring it out here. And now it's at 0. So this is the smallest value our terrain should take, and the highest should be 0.5. And we should... Yeah, we probably don't have... Yo, what's up, GDs? We probably don't have any terrain. Now, the terrain never goes above this one. E height. Yeah, now it works. Yeah, so now it works. But if we heighten the terrain, to max, then we get this problem. But yeah, so then we get this. So yeah, this is not a solution to our problem. We need to rethink the height range implementation here. Is the snow working? Somewhat. So it's pretty much this. It starts to break when, let's see here, when we're at height range minus height offsets. That's when it starts to break, right? So when we have a height range of 0 to 1 and we have a height offset of the snow of 0.4, it starts to break above 0.6. Charco, what's up? Yeah, dynamic terrain indeed. And hello again. GG's, from a very high level, what is the solution for a snow-like effect in games? Don't know if I entirely understand that question. But like, I mean, snow has always existed in games from back, always. The implementations, however, the quality of the implementation varies quite a lot. Simplest solution is just a material swap, right? And then the best snow I've ever seen in a game is probably Red Dead Redemption 2. Jesus, that game does so many things. Extremely good. Haven't played Horizon, but I reckon they do a lot of things extremely well from what I've seen as well. Their cloud solution is just incredible. But in broad terms, it's a material change and then displacement based on a displacement map, basically. And that's what we're doing here. But we want to transform our activity texture to a displacement map, and that's the process we're in right now. But okay, I'm starting to think that we might need to introduce a second height map, or height range rather. But how do I want to do this? Like, I want to do this in a way, I don't want to do a quick fix now. I want to do something we can keep in game. So it's pretty much, what it all comes down to is that when we store values to our textures or compute buffers or whatnot, we want to store it in a normalized way. We want to store a value between 0 and 1. But then we need to transform this value to something that makes sense. We could do... Like, basically what I'm getting at is now we define a minimum value and a maximum value, and our terrain can only be between these values. So we're using this max and min for multiple different things. I wonder if a better option would be to define a boundary for our world, a minimum height boundary and a maximum height boundary for our world. And so everything in our world can only be between this height and this height. And then we limit our terrain even more. So maybe our terrain can only go between half this value, so 0.5. So although our terrain can only go to half this value, the rest of our objects and things can go up to this place. So this, when I'm talking about a boundary here, I'm talking about limiting everything. So if we have flying creatures, we limit them as well, so they can only fly up to this point, basically. So when we do our height map, we base it on these limits instead. So basically, the difference between what we're doing now and this is just that we take the limit we have, the height range limit we have, which limits the terrain, we move it up, and then we add an additional limit to the terrain. I think that's the best option, honestly. Fabic, so when it comes to Red Dead Redemption 2 and balls shrinking, I don't think we will go... I'm just a one man, so we will probably not implement that, but we will see. And thank you so much for the super as well, the donation. I appreciate it. Definitely keeps me going. Thank you, thank you. And Charco, I think RD2 and MHW. MHW Iceborne had some nice snow. Don't know Don't know what that is short for, but let's find out. Is it Modern Warfare? No, Monster Hunter World Iceborne. Ah, I haven't checked that one out, but I reckon, like most games, most, if not all, AAA games these days make snow incredibly well. Fabic, well deserved. Thank you again. Thank you again. Appreciate it. GDs. So long story short, you paint a texture and update displays some shape in the world based on that texture. Exactly, exactly. And that's pretty much how height maps for terrain works as well. So let's take our terrain, for instance. We have a height map, a texture that describes that describes how high the terrain should be at certain points. And we want to do the exact same thing now with snow. It's just that we want to add an additional layer. But yeah, you paint a texture and you update / display some shape in the world based on that texture. That's the gist of it, pretty much. But, so in our case, I think this solution is definitely where I want to go. So it's something similar to what we do now, but we just want to add one additional constraint. So we could do this. So let's clean this one up a bit. I want to change this one or keep the change. And then we do this. We jump to our terrain base. This one defines height range here. So in our current implementation, it would probably be as simple as doing this we don't use anymore. I should really clean this up a bit. Range patch. So this is where we want to limit it. Height range. Yeah, we use this height range for quite a lot. We actually use it for all things. And that definitely breaks it a bit, honestly. Or makes it a little bit harder. Do we use it here as well? Hmm. Data real value. So it's basically, in our textures, we store it as a value between 0 and 1, right? And then when we read from these data textures, we want to transform that value, that normalized value, to a real value. And that's when we use height range every damn time. So I'm wondering, okay, so that's one option to redefine how this one works, or introduce an additional range. Or when we package the data here, we don't make it depend on that height range. But then it's a question of what do we make it depend on instead? And previously today I said we can make it depend on, so we can make it relative to the terrain ground. But if we want to do that, we need to set it here, and I want to avoid that. Do we have anything else we can make it relative to here? pretty sure that our best option would be to rename this one to probably terrain data range, or terrain data value range. So this is the range all of our terrain data will be, right? And then we introduce a separate boundary here that is our... I've been wanting to introduce one of these for a while, so pretty much our world boundary. We can't go outside of it. Yo, what's up, Cynic? New microphone, question mark, question mark. Now I just added some filters to it. Most importantly, noise gate. And noise suppression. Yeah, it helped quite a lot, actually. So height range. And I would probably like to rename it in shaders as well. Fuck it, let's do it. Let's make this work. But then again, if we do terrain data value range, do I really want to define it here, or do we want to define it somewhere else? I think we need it here. Unity has a variable type range, question mark. No, I actually implemented this myself. It's just to minimize some stuff. Don't know how. It has been quite useful. Very simple. I used vector 2 previously as well to specify it. You can probably still do it with vector 2. I just wanted to be a little bit more explicit. Okay, I think we're gonna do this. Let's see. Height range, do we want to go height range? Okay, we use it in a few places here. Let's rename it. So this one we changed to terrain data value range. And then replace this one with terrain data value. Hopefully won't destroy too much. Yeah, we probably don't need this one here, actually. We'll see. What do we have right now? How does it look if we run it? I'm always a little bit afraid after having done a big rename. Yeah, we fucked something up, that's for sure. Rain patch. Here we use height range. Still. Oh yeah. Okay, I know. But height range, I still think we want to do. Let's see, height range. I'm pretty sure we want to do this. No. Okay, and the reason our terrain didn't generate with a nice noise is because we need to change it in the editor as well. I think that's the only problem we have. Terrain data value range 0 and 1. So I think this is a little bit more straightforward what it does. So all our values we save related to the terrain is stored in that one. Do have and it still doesn't work here. Yes, beautiful, but we're back at where we started. And now we can introduce something called private bounds. Wonder if I want to. So the bound, this is going to be the bounds for the full terrain. So when it comes to X and Y, we want to base it on dimension. But when it comes to Y, we want to base it on, we want to define it ourselves, I think. So for instance, if we set, so X and Y will be the bounds of the full terrain, but the Y will be the minimum and maximum where anything on the terrain can move. So like this will be the lower and upper bound of the world pretty much. So if we throw anything, or if we have a creature that flies or anything like that, they can't move above these bounds. And when we do our activity texture creation, we're gonna store the values relative to these bounds. But then again, when we save it to the texture, we only have 8 bits to play around with. We could probably define the texture with more bits, but I think I want to avoid that. We don't want to make it too big. So what I'm trying to say is we can only store I don't know exactly the precision when we get to floats, but we have a set number of values we can represent. So what I'm trying to say is, if we make this bounds, if we make the distance between minimum y and maximum y too big, we are gonna get then the step length will be too big. So when we store a value, a height value to our texture, the difference in real world distance will be big between a step of 1 in the saved values. I don't know if that makes sense, but so we just have to keep that in mind. And I wonder if we actually want to define it like this. We have bounds here, and then we do care about this one. No, we don't. Terrain height bounds sounds too similar to what we had. We can probably do, or okay, let's do it like this. Private float dimension. Dimension. Let's do bounds. Bounds. Oh yeah. Dimension subdivided. We actually use this one. How about limiting the max height to max height minus max snow depth, so the snow value is at max terrain? Yeah, like that could probably work and be one solution. I don't know if I want to make it that specific to snow, but we could probably do something similar. What up, Redstone? I'm wondering, I think I want to do it like this. We're gonna do something similar, Fabric, but when we create these bounds, we're just gonna take terrain data value range max and like multiply it with 2 or something like that. So bounds, we want to create it, generate. There's a lot of things we can clean up here as well. Old solution. Old solution. But let's do this. So when we generate it, and we calculate all of this stuff, the first thing we do is having no problem just throwing ideas. Yeah, we're gonna do something very similar, so that's nice. I appreciate it. But we can do bounds is equal to new bounds, and what does this one take in its constructor? Center and size. So we just do transform dot position. And then size, is this, it's the full size, right? So we probably want to do, when we create these bounds, we want to do plus this is going to look a little bit rough, but 2 times rain data value range y max, and then new vector 3 dimension terrain. Actually, two times terrain data value range max dimension. I want to draw these bounds, so let's see if they are correct. But I think so. So we define the range of the terrain data. So what is the, so for terrain data height, it's basically what is the minimum height and maximum height of the terrain, and then we define the bounds of the entire terrain to be 2 times that in the height. So in practice, this would mean that a creature that flies cannot fly higher up than 2 times the topmost point of the terrain, basically. But let's draw this one real quick as well, just to see if we have private void draw gizmos, and then gizmos.draw wire cube. Don't we have with bounds? No, maybe not. But we do bounds.center, bounds.size. And let's see what this yield. So terrain data value range 0 and 1. So bounds should be, and I offset it. I offset the position of the bounds as well because we want the lower one to be at 0. But yeah, we'll see. Where do we have our bounds? Don't we have a bound? We're drawing the bounds. Did I draw the wrong bounds? Now draw wire cube bounds. We do have the bounds of the terrain patch, right? Maybe not. Because I can see bounds here, but it's per terrain patch. That doesn't make any sense. Oh yeah. Entity draws bounds. Okay, so those are the bounds we get. Did I terrain base? Ah, on draw gizmos. There we go. Yeah, that is why the gizmo function was grayed out. On draw gizmos, not draw gizmos. Derek, it's funny how often we write a piece of code and when we see how it works, we go, well, that doesn't make any sense. Yes. Definitely. Too often in my case, I would say. Okay, so here we go. Now we can see that we have bounds per terrain patch. I'm a little bit... Yeah, I think those bounds are a little bit wrong. Maybe. Yeah, we go a little bit deeper than we should. Or do we? Yeah, a little bit maybe. Maybe not. But we also have bounds for our full terrain patch here now, so we can see when we have a data value range of 0 to 1, that's not really that high of height differences between the lowest point of the terrain and the highest point. And we can also see here that the bounds for the full terrain is not as high as one would expect. Pretty much our character don't even fit into it fully. So yeah, it all depends on, we could go, when we create these bounds, we could probably go as high as but then again, if we do this, where do we have it? Environment. If we do terrain data value range, we go 0 and 5 instead. So now, if our terrain data value range is between 0 and 5, our boundary will be between 0 and 10, and I think that's a better value. 5-meter mountains. Yeah, we might want to change terrain patch, generate values. We might want to change Berlin noise data value generator, UV offset, UV scale, noise scale. One. Derek, thoughts on how the snow will behave when interacting with water? Lots of possibilities there. To be honest with you, I haven't at all. But definitely a lot of possibilities. A little bit scary as well. Most straightforward answer would probably be... Ooh. Okay, the first question is, like, do we freeze the water or not? But otherwise it would probably be just melt it when it hit water, you know? Sorry, I was muted for quite a while. Did I answer your question, Derek, about water and snow, by the way? Or was I muted during that rambling? But yeah, we can see here that the bounds for terrain base works. And this is a pretty good height, I would say. Oh, fuck it. But then we have trees. Trees are probably not affected. I will get to that later on. This works for now. So what we can do now is that Derek, no worries, we heard you. Oh, nice. I didn't. I just muted it for a short while then. Nice. Yeah, Derek, I'm for freezing the water. You could do some cool stuff with depth and seeing stuff frozen under the ice. Oh yeah, definitely. Fuck the possibilities, but also the time, right? I would love to freeze water. I would love it. But then, yeah, and then also if you have water with a lot of gradient changes, so the height of the water changes a lot, that implies that it's a river, and rivers don't freeze as easy. Oh, fuck. Love it, but also the time. So the idea now is that we send down bounds instead. So when we work with, let's see here, when we work with activity dynamic output, we send down instead of terrain data value range here, we send down the bounds, terrain bounds, and in our procedural snow, instead of working with terrain data value range here, we send down bounds as well. So it should be terrain base, it's terrain activity output, terrain data value range, blah, 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 blah. Let's change this. to rain bounds. We change that one and let's create some new lines. Set vector. Okay, we do it like that, and then we jump to our snow shader and we change this one to rain bounds. And then when we calculate displacement height here, we do in our case, it's okay. Our terrain is located at 0, 0, 0. Don't know if that will always be the case. But if we know that it's located at 0, 0, 0, we can just do 0 here and terrain bounds y here. Oh, one more thing. Terrain value, we want to change it here as well, right? Terrain data value range. So when we pack it, we do inverse lerp 0, 1. This one, ooh, this is just a, so we probably want to do float, 0, terrain bounds, 0, terrain bounds. I wonder if we want to do inverse lerp again. No, we want to do lerp. Yeah, we want to do lerp here. So when we pack it down, we take this position and we normalize it between 0 and terrain bounds. So this value is between 0 and 1. And then we unpack it here, so we get the correct object space y. And then we can compare it to this one, or we can do it, it's not really a multiplier, but we can do, let's see here. So this is object space y, this is object space y. So we get the difference between those, and then we take the minimum here. I think that's correct. Let's test it before we rename this one. We don't get any displacement. What have we missed? Get a little bit of a weird. Okay, we probably don't write the data. And I know think where we're getting this, but yeah, it's okay. So the max height, high can we go? A little bit worried about this one. I get the feeling that, okay. We can see here that the snow offset is still tied to So the terrain is at max height here, and so is snow. What the fuck? We not send in the correct terrain bounds here? I don't think we do. Yeah. Set vector terrain activity output terrain bounds property name. That's the... yes. Probably want to rename this constant, but yeah, what we want to send in here is bounds size. There we go. Is that roughly... yeah, that's probably correct. We can try it by doing snow. Yep. And then here comes the question, do you... although I like this, so we get thinner snow here relative to normal. That's probably what we would get. But something I'm a little bit worried about, honestly, is the shading here. It feels like... since the height can only be 256 different values, we get this. We can probably smooth this out, it's okay. Okay, let's see if we can get the displacement to work as well. Very nice work, bro. Thank you. Appreciate it. Yeah, we're moving forward. So why don't we get our displacement? Maybe we should check this, actually. Let's see if we write it to the texture. If we do, we know that the problem lies with the snow shader. So we can do... let's take this snow and move it down. Let's take the ground, change it to, what is it, 1.5. Yeah, we no longer write to our Or actually, is it 2.5? Now we write to this one. To this one. That's weird. Rain bounds, is it... So we write to this one, but not this one. Could it be? It could probably be that we don't set this one. I don't think we set it correctly. Where do we have it? This one here. Yes. Hmm. Still not working properly, huh? It was up underneath. Unity extension in VS Code is not working properly for me. I didn't even get any Unity IntelliSense. Oh, I've been there. I don't remember how. It's something in some settings you have to change. Maybe it's in project settings. Okay, why isn't this one working? Terrain bounds. Terrain bounds. Yes. Do we have that in the snow as well? Yes. Come on. I find it extremely weird that everything else works. I need to edit preferences external edit, but that doesn't work. Oh damn, that sucks. Actually, it might be in position, inverse lerp. Yo, what's up, Little Miss Murder? I hear you, I hear you. We've started playing around with the activity texture and just implementing some simple snow, or what I thought would be simple. That's pretty much what we're doing. Why doesn't this one work though? And then I want to do... Actually, let's take a look at activity. Activity debug. I think this one we oh yeah, I know. Activity, terrain activity data. Do I? No, terrain activity, dynamic output. Pretty sure we set these right. Yeah, this is what we have. We set this on awake, but we haven't really created this one just yet. So we wait with that, and in generate, okay, this has to be it. Yes. Okay, nice. Okay, finally. Looks a little bit rough. But now we can move on to some other stuff. That's nice. Dragon Dad is so sick. Yeah, I think so as well. Even though, like, if we try to analyze this result, like everything that is wrong with it, there's a lot of things. I still think it's very nice. Love this stuff. We do. It should react to everything, every object in the scene that has a dynamic entity attached to it. An entity is not the Unity entity system. This is something we've defined ourselves. But pretty much everything in this game is some sort of entity. It could be static entity, dynamic entity, playable entity. And this should react to everything. So for static entities, it just reacts once, because we know that those entities are static. And then it should react to every dynamic entity. Cypher Dude looking good. Yeah, I think so as well. Like, there's a lot of improvements to be made, but all in all, it looks pretty damn good already. Although, starting to think, so the banding we get here, I think it could probably be I think I know one way to decrease it, actually. I'm gonna try that real quick, but I think it has to do with the amount of different numbers we can represent our height with. We only have 256 or something like that. We have a set amount. But when we read our height map data and set the height of the vertices, we do it by a point sampler, I think. If we just sample it bilinearly, we get rid of this, I would guess. We can try that and see how it looks. Charco, how do you feel about designing the UI and menu for a game before working on gameplay for an RPG? Like, looking at what I'm currently working at and what state we're currently in, I don't really work by the workflow of finish gameplay first and then move on to visuals and so on and so on. So I don't know if I'm the correct person to speak about this, but like, I like to vary things up. So like, I think you can go and design the UI before gameplay, but like, if you want the correct answer, you probably shouldn't. But you know, I just think that it's funnier, or it's I like to work with things that look nice. For me, it makes it easier to work with. That's why I like develop gameplay and visuals in parallel, because I just enjoy working like that more. So, like, my opinion, go for it. I'm probably going to do something similar myself. We're probably going to do some visual UI implementations before we have all of the gameplay implemented. E-Dragon, did you finish the water shader and water filling system? It's not finished, but it's in a good state. The reason why we moved on to activity texture and this stuff is because we want to use the activity texture with the water as well. Like, we want to create foam on the edges, and we want to ripples when somebody walks in it and things like that. So it's in a working state at least, and looks. I have some shorts on my YouTube that shows how the water looks right now. Sorta. At least shallow water. Work on what motivates you that day. If you don't want to create a battle system, work with... Exactly, that's pretty much how I do it. But I try to have some structure around it. Because I noticed that if I wake up and I work on my game and I want to work on feature X, and then if I don't have any rules for myself as soon as I get to the first problem with feature X, I swap focus to feature Y, you know. But yeah, I think it's important to do what you can to keep yourself motivated. And in my case, that is developing visuals in parallel with gameplay. Charco, I've been designing my UI for over a year and haven't touched gameplay more than checking inventory items and skill UI elements. Yeah, I think that's okay. Yes, Charco, we're doing both Twitch and YouTube. Eventually, I've said this multiple times and for a long time, but eventually we're going to get some visual chats up and working on the stream, so we can see, so people that watch on YouTube can see what Twitch are writing, and people that are watching on Twitch can see what YouTube are writing, you know. But that's still a work in progress. I'm a little bit afraid of using third-party solutions for it. Is that not against Twitch TOS still? It is somewhat. Like, I know that I brought it up on stream and showed the rules, but like, I would really like to have it though, and I've seen other people have it without getting any repercussions, you know. But yeah, we're gonna have to. I have my own chat solution partly done, but before I actually show it on stream, I'm gonna read through the TOS thoroughly. But yeah, it's a weird rule to have, honestly, because it's very confusing for people watching on YouTube when I answer Twitch chat, and that's why I always try to read the question before I answer to it. But yeah, I just want to check real quick here when we do terrain patch. Data real value. Terrain data value. Shit, I need to... Working with... Going way too broad here. Yeah, remap. We could do data float value, data byte value. Oh yes, we're not working with... Oh, that's true, that's true. If we were working with textures here, we could probably bilinearly read it, but we're working with compute buffers this time around. That sucks. But then again, compute terrain data buffer. Since we have it like this, we have a lot of control over it. So for height, we could probably work with float instead. That would be way nicer. So I suppose it makes you engage more, which ain't a bad thing. That's true. Pato Lance, what's up? I'm starting a study of shaders for Unity. How did you create this cartoon shader? Do you use graph shaders and need to apply them individually to each mesh? I have a video on my YouTube on how the cell shade shader is implemented. And in my case, instead of doing it as a post-processing effect, I did it as individual materials. And that's because for my game, I want some objects to be cell shaded and some, or like the environment to not be cell shaded. So it just felt natural to do it per material. But you can definitely do it as a post-processing effect as well. It shouldn't be that hard. Depending on the result you're after, you can do it as a single pass post-processing effect. Although if you want a little bit of a better result, you can do multiple passes where you pack data which you use in your cell shader. The possibilities are endless. But what it comes down to, pretty much cell shading is just, you're just truncating a lighting calculation basically. I recommend watching my my video about it. Okay, I don't think we're gonna hate that. So yeah, we store terrain data height as byte, which means that the banding we're seeing is because we can't represent that many values, only 256. And if we have a height minimum of, so what is that actually? Let's see. We have environment 0 and 5. We have a height difference of 5 meters and we have 256. Yeah, we can visualize a height delta of 0.02. So every height delta is around 2 centimeters, and that looks to be what we're seeing here, the banding. Like, are we gonna do some, maybe we're gonna jump back real quick to terrain data tomorrow, just to get rid of this banding. So I'm talking about this banding right here. This looks to be about 2 centimeters. I guess we could shade it. We could solve it by shader as well. It's not that important when it comes to all of these, but when we start working with these, we probably want to smooth it out a bit. Yeah. But this one is done. I'm gonna commit this one real quick, and I'm wondering. Let's wait with that one because I'm gonna have to commit a lot of different changes as well. It's pretty much all we have done today. So let's take a look at procedural snow again. Very simple displacement so far. Very simple. Recolor based on displacement height. This one we can do real quick. And it's just so the trampled snow, so the lowered snow, I just want to recolor it a bit so we can better see how much we have displaced it pretty much. So we have lowered color here. But we want to colorize it in the fragment shader, so we need to send down some information to it. And I think this is not really a displace multiplier. So we can't really send this one down. One solution could probably be to send down position OS and position OS displaced. Or but if we do it like this, displace amount, and then we do and then we need to recalculate it to be between 0 and 1 because I want to do a nice lerp between colors. So we could do displace multiplier. Would be very nice if we could change this one here. If we could change this one to a multiplier instead. So we get the height of this one. This one can be greater than this one. I wonder if we want to do displace amount divided by... Is it like this? If this one is 1 or max... Yeah, we're gonna go... And we do a saturate on it. And then we can do, if this is the correct way, we can set it like this. And then we use output.displace amount times height offset. And then we have displace amount here. Let's just do return displace amount. Input dot displace amount. So if we don't displace it, it's 0. If we displace it, it's 1, I think. Something like that. Oh, just this looks so good. This is beautiful. We can use displace amount here to recalculate lighting, because less light will... This is pretty good for snow, honestly. Maybe not the pure black down here, but... So maybe it's not that much about changing color. So we have color and then we have lowered color. So we definitely, I think we want to switch. So color for untouched snow, lowered color for trampled snow. But then we also want to change ambient multiplier and shadow amount and some other light related stuff to make it look good. Derek, subsurface scattering a possibility? Yes, like that's a... I haven't worked that much with subsurface scattering, but isn't that like a perfect example for when you want to do subsurface scattering for snow? Because you have light penetrating the snow and bouncing around inside the snow. Some get out, some don't. So I definitely want to explore it. But then it's also a question of, can we hack it a tiny bit? We're going to have to do some... That's a very good point. Let's explore subsurface scattering for lighting. And I like this, what we get here actually reminds me a little bit of subsurface scattering, a tiny bit. Oh, this looks beautiful. Love it. So if we do this now, instead of just returning displace amount, we do color. So color is equal to lerp between lowered color, and input dot displace amount. And then we use color here instead. E-Dragon, just ditch collection game and do snow running game. Yeah. Ambient music, some good skybox and snow. Hell yeah. Cozy snow running game. And then we do... That's lowered color. We can go, if we go black, we get something like that. Ooh, do we only get this? Maybe. And we haven't even recalculated the normals just yet. Oops. Already getting this nice result. Pretty sick. And then we don't even use neighboring vertices right now either for additional displacement to get a little bit of smoother edges. Fuck, this is looking good. Love it. Do we actually have... Do we have a little bit of snow sticking up in the whole of the stool? Yeah, we do. Beautiful. Jesus. Okay. Yeah. This is probably a case where, sure, it looks nice. I like it. But we probably want to check what the neighboring values for this one is and lower it a tiny bit at least. If you got snow in your stool, you should check with a doctor. You probably, it's probably over, man. Fuck, this is the default activity texture all over again. I'm gonna play around with this one so much. It's extremely satisfying. Just look at this snow between the legs here. Jesus. This is not satisfying. There we go. I want to see... Okay, we have some weird physics going on here. And then we have... Yeah, that's true. Okay, if we do it like this, I want to play around with it a tiny bit. I just need to do... procedural snow, lowered color. I'm a little bit... We're going very dark here. It looks nice, but that tells me that something is a little bit wrong, because we're going pure black, but we're not getting pure black, but... probably something with the light calculations, but yeah. And then if we do... mattress, pillow. Okay. I like the physics. We can work on that. Mm. How fucking cool is that, honestly? It's very nice. Look at this. Don't mind the physics, but... what the fuck? Oh, I don't know if we're gonna have this high resolution on the activity texture eventually. Maybe. But what we're seeing here is... I love it. What is the weight of this one, by the way? 20 kilograms, and it flies around like that. Really? Fuck. I don't know about that. That's more like it. Yeah, he's crazy strong. Oh no. Yeah. Okay, but this is very nice already. Very nice. And we still have a lot of different improvements to make, but I think it's a good idea that we implemented this and started using the activity texture, because now we're finding out what is practically good to use, what do we need to change, and we have already added a few changes to our activity texture, like how we store the value, what the value is relative to, and so on and so on. I reckon we're going to get a lot more of similar stuff when we try to utilize the velocity texture. I'm actually also thinking about trying to dynamically update it using a simple fluid solver. GeoStam, probably. But yeah, exciting times ahead. Unfortunately, I have to run now, but fucking great session. I haven't really decided just yet what we're going to do tomorrow, but we will probably continue with the snow, see if we can improve it a bit more. Maybe have to extend the terrain system a tiny bit so we can store height values as floats. I think that would be a great improvement to like removing the banding. But yeah, we will see tomorrow. Thank you so much for watching, everybody. Appreciate it. Good luck to you too, Charco. But thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.